Okay, I'm back, and now we're ready for part 2 of the lab, which is entitled Inelastic Collisions. So this time you're going to click on the green button at the bottom of the simulation labeled Inelastic Collisions. So we were doing the explosion, and now you need to click on the button that says Inelastic Collision. Okay, you're going to put in the following initial conditions. So the initial mass of the red cart needs to be 2. The initial velocity of the red cart needs to be 2. The initial mass of the blue cart needs to be 3. And the initial velocity of the blue cart needs to be -5. Okay, so notice that one of them has a negative velocity. So what does that mean? A positive velocity means it moves to the right, and a negative velocity means it's going to be moving to the left. So if one of them is moving to the right and the other one's moving to the left, they're going to collide. And since it's inelastic, they're going to stick together. So calculate the initial momentum for the red cart. So initial momentum would be initial speed times mass of the red cart. And then do the same thing for the blue one. And then add those two numbers together to get the sum of the initial momentums. Okay, now go ahead and hit the start button, and then after they have collided, note what the final velocity is when they're stuck together, and then calculate the final momentum by multiplying the final velocity times the sum of the two masses, because they're stuck together. Okay, and then answer the question, how does the sum of the initial momentums compare to the final momentum of the system, and was momentum conserved? Okay, now we're going to reset the simulation, so it's still going to be an inelastic collision, but you're going to reset it. This time you pick the masses that you want to use, and you pick the initial velocities. But remember that one of them has to be negative so that the two will collide with each other. And then you are going to calculate the final velocity it should have after the collision, so calculate it, and then you're going to measure it and then see if those two numbers are the same. Okay, now we're going to go to part 3, which is the elastic collisions. So this time you're going to press the button that says elastic collisions, and this time what's going to happen is they're going to hit and then bounce off each other. So you're going to give the carts the following initial masses and velocities as listed in the lab. You are going to calculate the initial momentums, add them together. You're going to measure the final speeds of the two carts as they move away from each other, and then you're going to calculate the final momentums and then add them together. So how does the sum of the initial momentums of the system compare to the sums of the final momentums of the system, and was momentum conserved? Okay, you're going to reset the simulation. This time you're going to pick two different masses and two different initial velocities. One of them has to be negative so that they will hit and bounce off. Then you're going to measure the final velocity of the red cart and you're going to use it to calculate the final velocity of the blue cart. Okay, and then once you've done it, you're going to actually measure the final speed of the blue cart and see how close you were to that answer. Okay, now you're going to go down to the post-lab questions, and you're going to answer all of those. So some of those are going to be elastic collisions, and some of them are going to be inelastic collisions, but you should now know how to answer them. And so do all of those problems and then email the lab to me, and we're finished. So I will see you next time.